Welcome to the project IoT project part 1, which is related to Arduino development and Labview project. First of all, in this project I will be covering these topics. The first one will be system sketch, and second one will be showing the code from PI controller and low pass filter, and followed by temperature sensor and Arduino libraries and other simulation stuffs, and finally with uploading the data into ThinkSpeak, including some precautions that we should take for data security. So in the very first slide, it is about the system sketch. So in the air heater simulator is being used here, where the temperature of the environment is measured and passing it through the low pass filter. It is given into a controller, and the output of the controller is sent back to the air heater to control the temperature to heat the air. And yes, there would be also a set point which is set. That part is missed, I guess. So here there should be some one set point which will set the temperature. So moving forward to the sensor, a temperature sensor is being used to sense the environment, the temperature, and the connection diagram is as following. And Wi-Fi module is being used also here, where the connection has been established by this diagram, and due to Wi-Fi module not having enough power to broadcast the data to Wi-Fi router, because of the power supply from this cable from computer was not having good enough current, so external power supply is being used. And this is the actual implementation of the circuit, where it shows that this is ESP8266 module, which is Wi-Fi module, and PWM output is being simulated by a LED light. And this is the sensor, which is TMP36, to sense environment temperature, which is being uploaded into. And we can see less than a minute there was an update which was 25, and in the private view we can see more points. So it is at 23.3. As Arduino Uno have only one serial port, Arduino Uno's 80MB has only one serial port, so software serial has been used to communicate with the Wi-Fi module. So these two pin will be used as a RX and TX pin for communicating Wi-Fi module. And these are the libraries which is being imported here to simulate air heater, and also to work with the low pass filter and the controller. So we can have a look on the library. So this is the C++ file for controller, and the controller is used in the equation, which is discrete format. So these are the values, and set point has been hard coded here. 25, and this function is called over and over within a time period. And this is the low pass filter which is being used in the code. The low pass filters parameters are here initiated at the very beginning of the code, and this is the equation used to execute low pass filter. These are the variables which is used in the code, and these are the IDs and the API key to push data into ThinkSpeak. And in the setup, initially the serial port is being set to 9600 baud rate, and also the ESP module is being also set to 9600 baud rate. And after some checks, Wi-Fi module is being initiated. In the main loop, first the Wi-Fi is attempting to connect to a router where the password and Wi-Fi connection network name is passed, and these values are stored in a string which is in a separate file. Analog read has been done from the sensor pin, and this value is later converted into volt. Some prints on the log just to verify whether the connection is whether the sensor read is correct. After this, the value is passed into low pass filter, and filtered out value is then passed is converted into degree temperature, and this temperature is sent to ThinkSpeak to save it on the cloud. After that, this temperature value, which will be output of air heater in the real implementation. So here this temperature is being sent to pass to PI controller, and as a return the control signal is being generated, and this control signal is again sent to the heater simulation, which will have effect on the heater signal, and the temperature will be increased, and the resultant temperature of the output of air heater will be calculated, which is stored in heater output. And this function has been used to write in ThinkSpeak. So this output, this variable is being taken, and it is directly pushed into using the ThinkSpeak library. And yeah, I am holding the temperature sensor, so air heater, the temperature is increasing, and we can see that the value here in the graph is increasing because the temperature is also increasing in the board. And as you know, there's a 15-second delay for if we want to push data in ThinkSpeak for free version. In this second part of this project, I will be showing that Labview software has been used to simulate air heater as well as PID controller, where the environment temperature is being captured by TC74, and I2C's protocol is being used to communicate with TC74 to get the temperature sensor value. So the circuit diagram is more or less like this, and rest of the part is being implemented in software. So if we jump into the LabView software, so this is the implementation. If we focus on the circuit diagram, so this is the air heater model which is being used to simulate air heater, and this is a Fuji PID simulator, Fuji PID controller simulator, and this the output of the air heater is being fed back through the scale which converts temperature to voltage to the PID controller, and these are the some default values which has been considered for PID controller. And this part shows the communication to the think speak, to send data to think speak, and COM3 port is being used to capture data to communicate with Arduino. So if we simulate, if we come to the GUI, then we have a graph display. We have also the API key insertion text field, and this is the display of the API string which is finally being executed to send the temperature values to think speak, and this is the field number which can be selected to send information to different fields, and there are two strings which indicates text field which indicates room temperature and the output of the heater. So now if we hit the if we simulate the LabView program, there will be the Fuji's displays being visible, and as we can see, the room temperature is 22.8 or 23, and the set point is set at 26. So there are some voltage which will try to increase the temperature of the air heater. So if I manually try to increase the temperature, you can see that the room temperature is increased, and that's the reason being the output voltage is being reduced because it is already crossing the set point. Yeah, so this is the LabView simulation. This is the part of the think speak where data is being updated. When I was hitting it manually, the temperature went up to 28 degrees, and later it came down. So finally we will talk about some security of data which we should consider. The number one thing is updating periodically the API key, which will save us from external attack or false information, and also we can control the access to the network. A key point would be using password and authentication, and to change the authentication periodically, including checking it maybe not in every transaction, but maybe with some weeks or months. And encrypting the protocol would be another good part to stop hackers to send bad information in the server. Also, we can group the different sensors in segments which are more important or which are less important, which will which can have level on the risk if we can discard or not. So that is all for this project. Thank you.